Alright, as I mentioned earlier, I want to teach you how to effectively test diodes, both when they are integrated within a circuit and when they are examined outside of one, so that you can confidently ascertain their proper functioning. Alright, to begin, we're going to perform a simple, straightforward test. As I mentioned to you, the purpose of this is for you to learn how to effectively test a diode when it's out of the circuit. When you have a diode removed from the circuit, as you can see, I have two distinct types of diodes right here. One of them is this particular diode, which you can clearly observe has a specific appearance, and you'll notice that all the pertinent information about this diode is actually inscribed directly on its body. The second type of diode I have here is physically much smaller, and you can see it demonstrated right before you. Now I will demonstrate for you how these diodes are tested and the proper way to conduct the test. You see, as I've mentioned, multimeters typically come equipped with a dedicated diode test mode. As you can clearly observe right here, my multimeter also features this essential function, making it quite obvious. You'll notice the continuity mode, marked by its distinctive symbol, and the diode test mode are integrated into one setting here. Any new multimeter you purchase will operate in precisely the same manner. I'll set the multimeter to diode test mode, which also functions as continuity mode, and then test its probes. So, as previously stated, the black probe functions as the negative one and the red probe is the positive. To test a diode for its proper functioning, this is the process you need to follow. We're going to connect the red probe to the diode's anode. You can easily see the anode and cathode that I've been discussing right here. The side of the diode with the line is the cathode, and the side that doesn't have a line is the anode. So we'll proceed to test the diode, and you'll observe that the multimeter is now displaying a digital reading for me. Okay, once it shows the reading, I'll reverse the diode. As I said, this time we connect the negative probe to the anode and the positive probe to the cathode. In this case, you see the multimeter isn't showing me any reading. So this means the diode is good, at least in the initial test. Okay, now let's move on to testing the next diode. We'll test this next one the same way. First, the black probe to the cathode and the positive to the anode, and we see it shows a reading again. For different diodes, the digital reading on the multimeter may vary based on its power rating and operating voltage. However, this is perfectly normal and poses no issue. So we'll test it right here, and we can see it gives us a clear reading. Now, if we reverse it once more, you'll observe that the multimeter displays no numerical value whatsoever. Excellent. This indicates that this diode is also functioning correctly. The second testing method, which is considered a routine check, is the short circuit test. This means the multimeter still stays in the continuity test mode. Now, if you come across a diode that you want to test, and your multimeter is set to the continuity mode, and you have correctly connected the multimeter's probes to the component leads of the diode, and then, if after connecting the probes in this manner, you hear the multimeter emit a continuous beep, this indicates that the diode is short-circuited or burnt out. There's absolutely no need to test the diode in the opposite direction. This is because a properly functioning diode should never emit a continuous beep, not even when in the reverse direction or when in the forward direction from the anode to the cathode. If a diode causes the multimeter to emit a continuous beep in even one direction, that diode is completely burnt out and defective, indicating total failure. This means it's entirely damaged. This is because a diode, even when current flows in the correct direction, that is, when it's properly biased, by connecting the positive electrical supply to the diode's anode terminal, this state is referred to as the diode's forward bias. This means we have placed the diode in forward bias. However, when you connect the negative probe, or the negative electricity, or even the circuit's negative terminal, to the anode of the diode, this is then referred to as reverse bias. Pay attention. When you connect the multimeter's red probe to the diode's anode and the black probe to the cathode, you have put the diode in forward bias. However, when you connect the black probe to the diode's anode and the positive probe to its cathode, you are placing the diode in a reverse bias configuration. So technically, a diode in reverse bias should not show a reading. When in forward bias, it must display a numerical reading. Now, even if you put the diode in forward bias, that is, you connect the positive probe to the anode and the negative probe to the cathode, which is the correct orientation for the diode, and the diode still beeps, causing the multimeter to beep, then that diode is also defective. Even if it doesn't beep in the reverse direction, but instead of displaying a numerical reading, it beeps like this in only one direction, it signifies that the diode is defective. You absolutely must discard it and utilize a properly functioning diode.